Hopefully, we're gonna be ready soon, as my next talk is on Kamailio configuration optimizations. And anyhow, we do quite good job at performances. So I will not have any interactive demo now here, but I will give you some tips, tricks on whenever you need to optimize a bit more. And here it's about caching, also some parameters of the configuration file that can help you, and also quite important how to discover which part of your configuration file is a bit too slow for what we would expect for a large deployment. So again, I'm Daniel-Constantin Mierla. For whoever I haven't met yet, I'm one of the main developers, or pretty much the main one at this time. But for those that don't know the history of the project, I will have tomorrow in the first session a bit of history. So now let's focus on the technical side. As I said, more on tips and tricks about optimizing Kamailio configuration. How many of you know Kamailio configuration file, or maybe how many don't know it? Okay, nobody? Then it's good, because you know it's actually a scripting language. And my last talk, just to make myself a bit of advertising, will be about the scripting languages, because now we are transitioning to a more flexible way. So this is actually about the native scripting language, which we kind of built from scratch, and is still there, still widely used. But with all this dynamic world, with web, RTC, or real time over the web and other mediums, we need to get a bit more flexible. And again, the last talk of the event, whoever resists to Wednesday evening, I'll have a description of what you can use now. So first to look at, it's latency. So what's slowing down? You have this beautiful configuration file, 20,000 lines, right, zip-wise, or Kazoo, or whatever other large deployments are out there. And then maybe it's not that easy to spot what's really not running that fast. So if you look at the core cookbook on our wiki and you search about latency, you'll discover a couple of parameters that you can enable or set some values for them to get some, in our case, log messages in the situation when some action, as we call these statements in our configuration file, are too slow. First would be the latency CFG log. So this is about printing the execution time for the main request route or the main reply route. So that will be like the root route block in our configuration file. So what's executed for a request, because it's a chain of actions there. And maybe you just want to get, okay, now this route block took that time to be executed. This is actually rather new, because I introduced it to check the performances of native versus Lua or Python or other scripting languages that we have now available. Maybe more related to this specific action would be the latency limit action. Here you can set a threshold, upper limit in milliseconds for the execution time. And if exceeded, so if one action is taking longer than this limit to be executed, you'll get a log message. So practically you can see, okay, now the lookup location is slow. Maybe I have so many active users that I need to increase its hash table or do other kind of optimizations. Because we do quite a lot of interaction with the database, and there are some modules doing a couple of queries, we have another latency-related parameter, latency limit dB. So this is measuring how long it takes to do a database query, no matter it's Postgres, MySQL, even dbText, and doesn't matter which module does one or many, it's for each query. So this is quite useful to detect whenever you have some maybe not optimized database, so not proper indexes or unique keys or too many records. I'll get later to it. And somehow the related, but not specific to latency duration, it's latency log. This would be, which would be the log level where printing these latency related messages. We actually have a dedicated module, so that's part of the core. But then we have a dedicated module where you can enclose which part of your config file you want to track into two actions or functions like BM, so benchmark start timer, and BM log timer. You can use as many timer tracking IDs. So here we want to know how long it takes to execute the lookup location. So practically, the action would be with the limit in the previous slide. Here you want to see it, and this is doing more than just printing the execution at one time. It's also keeping a bit of history, so you get some average printed. So because if you have a lot of traffic, you'll see, okay, the user log lookup took in average so many milliseconds. You can even compile it if you have the real-time library to get nanosecond precision for the execution of the config file. In between these two functions, you can have many actions. You can call route blocks, so it's not only for another action. So it's up to you to put as much as you want inside the start and log timer actions. And one way to discover which part it's slow when you don't know is like splitting into start stop or start log at the mid of the request route and then another start and stop at the end of the request route. And then you discover which one is slow, and then you keep splitting by two sections until you get and discover, okay, maybe some database related, maybe some DNS related issue, and if it's like T-relay takes too long, that's typically because of a DNS issue. Or if, I don't know, auth is taking long is because fetching the password from the database takes too long. Or maybe it's accounting, writing, and so on. Because we interact a lot with, or all this feedback is mainly through the syslog. Be aware that syslog actually is slowing down a lot. There are people, especially at the beginning of the learning phase of Kamailio, they tend to put a lot of log messages because they want to see what happens and have for each request coming to Kamailio a lot of log messages. If you forget to set it in asynchronous mode, the syslog, this is becoming a bottleneck because practically the library keeps Kamailio blocked until the log message is written and confirmed to be written in the syslog file. Depending on the syslog application that you use in your operating system, there are different ways to do it. I think this is for the classic old syslog. Practically, you'll have to put a dash, a minus in front of the log file to make this like an asynchronous writing to syslog. Different other like syslog ng or rsyslog might have slightly different options, but the takeaway here is be sure you configure it in asynchronous mode, the syslog demo, the syslog application. Of course, would be recommended to direct logs from Kamailio on a dedicated log file. Each of these applications, they have their own mechanism. They rely on this facility ID, in our case, log local 0, and you will need to also set it up in Kamailio config file. So this is what we provide as tools inside Kamailio configuration file that you can use to discover what are the slow parts of your configuration. Next step might be that, okay, I discover it's authentication, it's accounting, you will need to do optimizing of this operation or what's behind it. as one of the old good friends from voice over IP, now no longer doing. Who is knowing Stefan? Okay, so a lot of new people. I haven't seen many. So he was also involved a lot in voice over IP with the Gemeinschaft PBX. So cache is cache. So it's important at some point to go beyond what C code can optimize for you. As a summary, so there are a couple of modules that they do always database interaction, like authentication, DB, alias DB, group, speed dial. These are always fetching data from the database. So a way would be to optimize this, and of course some generic SQL-related modules like SQL Ops, obviously they interact with the database. Of course, first and very important is to have a optimization of the database itself, the table, so proper unique keys, indexes. Also don't keep like unnecessary records there, especially if you're a large deployment. It's good to move from one table to another. I've met a lot of issues with like people keeping accounting for 1 year in the same table, although they already build and so on. It's good to have it for historical reason, but don't really keep it in the same table where Kamailio or the SIP server is writing. Also for some operations, because like accounting maybe makes sense to have it in a central database and it's a single operation, but I have seen companies liking to do a lot of database-oriented routing, so having like a store procedure for doing list cost routing. That's fine. You provide a couple of parameters, source IP, caller, callee, and you get next IP address. And they do it as a store procedure. But then if you keep it like a centralized, and that's a slow communication, and you do it a couple of times for each request, that could be slowing down. So it's good that sometimes you move closer to your SIP routing engine. So you split between what needs to be collected in a central point and what's needed locally for routing. Different database systems, they have also this option to declare tables in memory. So sometimes this could be good, or the other generic option would be creating an in-memory partition and any kind of database server. Then if they created there, should be faster than the usual hard drive. This is getting lower and lower as required because we have this SSD, which tends to be quite fast right now. But anyhow, back to Kamailio and what you can use to optimize or cache information. We provide you a few modules. So we have first here hash table module. And somehow I got to the saying that if you don't have hash table in your Kamailio configuration file, then probably you are doing something wrong. Because it's really useful, and it's also the default config file for detecting attacks and blocking them by using a hash table. So what's this module? It's like a generic module offering you options to create as many hash tables as you need or as you have physical memory, and then store these key value items inside it. It's up to you to define like a table name and what you store inside it. And this module has a lot of attributes that you can tune. You can set like maximum lifetime for a value. You can set also auto expire if not used, or maximum lifetime would be like if it's even used, expired after a while. You have some function or variables. You can count items by matching the name or the value of an item. So you can get the reports out of it. You can delete by matching, so regular expression matching of some keys or values inside. So it's quite useful. If you are not familiar with the hash table concept, it's practically a list of lists. If you look at Wikipedia, there is a very good article and very easy to understand. So if you are not a programmer, you'll get a good idea. And practically, most of the database indexes, they use the same concept of like hashing of a key with a function that results in an integer or numeric value, which is then used as a modulo over a modulo number of slots you want to have in the hash table. So it's optimizing the search of values. The module is also offering some event routes, so you can initialize values inside the hash table when Kamailio starts, or also getting an event when some key is expiring in the hash table. Again, it's very flexible. That's a common, like, generic purpose module. How you use it, it's up to you. Already mentioned that the default config file, use it to block IP addresses when detecting it's like a flooding attack. And next slide, I'm trying to show you how you can add caching of passwords. So as I mentioned, authDB and authcheck, that's function exported by the ODB, it's always going to the database and makes a query. You have a registration, you have a subscription, you have an invite you want to authorize, even if it's the same user, then this goes to the database. What happens typically, there is a burst of messages after registration, like subscription for BLF and so on. So might be a good solution to just cache it, even for a short period of time, like 1 minute, half a minute, the password with the first registration, of course, when it's a successful registration, so the next one that comes very fast, subscribing for all my contacts, will get it from the cache. So practically, we have defined here a hash table, size 10. This is used at power of 2, so practically there are 1024 slots. So the number of slots is 2 power the value of the size. And we say it's expiring in 5 minutes, 300 seconds. Again, you can tune that as you need. Another quite interesting trick that you can do this time with authDB is this load credential parameters. If you haven't used it, look at it. Maybe you can use it also for other situation. Here you can provide, so this load credential, you can provide like a variable name equal column name in the subscriber table. So once the authentication is required or performed, along with the password, Kamailio fetches many other columns as you configure here, and their values will be in the configuration file after authentication function. We actually fetch the password again, separated than what's used inside, and we store it in AVP password, script variable. So this would be like, if you look at the default configuration file, you have route auth, and you can replace it with this route auth cache. The one from the default config file does also IP authorization with permission. I just keep it for the sake. So this would be more or less like in the middle of that default config route auth. So what we do here, first we check, this is a variable that looks in the hash table, SHT. This is the name of the hash table as we define it here. And this is a variable, and it's going to be used as a key. So $AU is authentication username, Daniel, Ole, whoever registered at that time. And this is a static string that we put here, actually, this : password. It's up to you to use. Only this is like a variable and expanded by using the value from that request processed at that moment. So if it's different than null, that means we have a value. And then we use PV auth check. This is a function from the auth module, which is required by authDB. So it's not new addition, is why I haven't really put it here. There's no change comparing with the default config file. And now the password is given as a parameter. So we have the realm that we take it from the from domain, the password and couple of flags, which kind of authentication, MD5, MD5 session, and whether to check if authentication username is equal, like from username to username. So these are flags that are documented in the readmes. If this fails, we challenge again and we exit. If we don't find the password in hash table, this is practically what we do now with the default config file. We use auth check. This is going to the subscriber table. We'll fetch the password. If everything is fine with authentication, this variable will be set with the value of the password column. Of course, if it fails, it goes with a challenge. But if it succeeded, so authentication was OK, inside the hash table, auth, with the same key, so authentication username and the password, we set its value to the value of the AVP password. And that's it. This is also in the default config file. So practically, what we added is this if plus this block. The rest is the same in the auth route block from the default configuration file, along, of course, with loading the hash table and setting the load credentials. And you can apply this for whatever other needs you have. You can have SQL ops to fetch your own data. You cache it for a while, and you check first the cache, and then, if not, you go to the database. The next module I'm going to talk about would be entry module. Hash table can be used for any kind of key, alphanumeric, numeric, it's up to you. But if you work with numbers, and we do a lot in telephony, prefixes, the IDs, and so on, might be suitable to look at entry module because the indexing method is way faster. So it will be any number will be found in the maximum length, or if you use the prefixes, it will be a match on a shorter path. So practically, with each prefix or number, you can associate a value, and that value is stored in a tree. When you do routing, you can match on this tree. Again, it's faster matching than hash table, but somehow suitable only when you have a limited dictionary. So like numbers, they can be only digits, maybe plus or a few other characters. But if you put the entire ASCII table, trees are no longer that. They are still optimized on searching, but they require a lot of memory because each node typically has many slots corresponding for each character. You can define, again, as many trees as you want. You can load values from the database at startup. You can reload later. And again, I use it quite a lot, especially like mapping a DID to a dispatcher group. So this prefix needs to be routed to that carrier. That carrier has a couple of gateways. So I have prefix to dispatcher group ID, and then dispatcher group ID will do round robin based on that or whatever algorithm you like. So entry, it's really good at doing such indexing. I added here because sometimes people need to share some information, and Redis is known to be quite used in the rest of the world, not only in telephony, for caching or fast storage. Even RTP engine, which deals with a lot of traffic and so on, relies on Redis to do high availability of the media streams. Andreas Grenning will present a bit more about the RTP engine, what they are doing with it, rather good application. And also some other companies, for example, they started with entry as number portability indexing, but then you have a huge amount. And then if you have like 10 Kamailios, updating in a single instance will require reloading, and then you actually have to do for each of these instances. And then accessing from external, like updating, removing keys from there was a bit too complex to do it on all the nodes. So you can go with Redis somewhere in the middle. There are variants, or not variants, alternatives. Memcached, which I think was first contributed by 1&1, was the initial option. Redis got more popular, or if you prefer other NoSQL databases, we have support for MongoDB and also Cassandra for as a connector from the configuration file. Routing. So there are more like caching inside Kamailio or outside as a suggestion with Redis. Redis, actually, I put here some examples from our configuration file. Again, can work with many servers. Karsten from NG Voice added also support for their cluster recently. So you can connect to many nodes at the same time and do any kind of operation you want with Redis. We have a CMD command exported to the configuration file. So it's very flexible. Doesn't require to work with a single Redis. You can have one for normal portability, another one for some other needs. So again, these are what you see with NDB are NoSQL, and they are like connectors from the config file. They can't really be used by other modules. It's more for you to build a configuration file using them. And the last section I have here, it's getting to optimizing the execution of the routing config. First, on scalability of the application, like how many worker processes, how we call them. So practically, Kamailio is a multi-process application. When it starts, it creates dedicated processes for different tasks, timers, handling UDP traffic, handling incoming TCP TLS traffic, handling SCTP. So per transport layer, we create a pool of processes. Some of the pools are per transport layer, like TCP. Some of them are per socket, like UDP and SCTP. And you can actually do it per socket with socket worker options. So maybe this is more used together with TCP eventually. Also UDP, I use it like I want to start, 16 worker processes for my real network interface connected to the phones. And then I still want to have like on loopback, but only one or two because I do monitoring, keep alive sending to Kamailio on the loopback. But then I don't really want to have 1632 or whatever large number for the loopback interface. So if you use socket workers equal 2 before listen, the next listen means, OK, I'll create only 2 workers for this, and is resetting after evaluating that listen global parameter. So that could be good on saving some resources on some sockets that are not that used. With TCP, TLS, we actually do multiplexing there, and we can handle HTTP. So also for some API, I create a socket on, I don't know, port 8080. And I don't really want to have the same number of workers as with SIP traffic. And then we have the asynchronous worker processes that are used by other modules. So this is also something that you can tune. We have asynchronous MySQL queries. That's only for inserts. So if you want to write something to the database and you are not caring about the result, you can delegate it to a non-worker process. So the routing on invite goes fast on, and inserting to the database, it's taken care by another process that never handles incoming SIP traffic. From the command line parameters, shared memory is quite important and private memory. We have our memory manager. You can choose which of these memory managers you want. I think by default we are now FM or maybe QM for debugging. There is an alternative contributed by the guys at Libon. Federico should be around here. Camille, which is a bit more optimized for TLS usage. In some corner cases, the name is just misleading there or a bit overlapping, but the history with the memory manager, it's the QM and FM, it's more or less the same algorithm. QM keeps a bit more debugging information. FM is more like for production and keeping lower overhead per allocated chunk. If you are not familiar what means a memory manager, it's like we ask from the operating system a large chunk of virtual memory, let's say 1 giga, and then we do micromanagement inside it. And then we need to keep track what's allocated, what's not allocated, and so on. By that, sometimes it's easier to discover memory leaks, sometimes it's a bit harder. Anyhow, back to the history, QM and FM are the old one, and their target or the initial design was optimized for SIP traffic as it used to be, I don't know, 10 years ago, where you have invite by in the range of like half a K, 2K. Now we have WebRTC invites with SDP, so then it's way longer. But because trying to optimize for that use cases, so it's very optimized for dealing with chunks less than, I don't know, 8K or maybe 16K. However, TLSF, it's maybe not as optimized for this range of chunks, but it doesn't have corner cases because it was discovered that when you, I don't know, have a 500,000 TLS connection, a TLS connection uses a lot of memory, buffers for encryption, decryption, and so on, keeping the certificates, the public, private keys there, and then cutting everything at once. Practically, Kamailio had to free 500,000 large structures, which were not in the optimized range, and then was practically a single list having all this structure, and freeing them was taking a bit, let's say that. With TLSF, you don't get in that issue, and probably we could consider switching to that as a default, given that OLED doesn't allow anyone to run UDP anymore, only TLS and IPv6. Anyhow, you can choose it at startup, so you don't have to recompile it like in the past, just use -X, and you can even have different, because we have two types, private share memory. Typically, you just use the same for both, so you use only the -lowercase(x), and we'll take care of setting the private memory manager as well. Share memory size, this is not as recent as choosing the memory manager, but still relevant to choose the size of the memory you want to have reserved per process or per instance. Core parameters related to memory, there are a couple of them that if you don't set them properly can slow a lot, especially memDBG. If you set it to a lower value, you will get a lot of noise in the syslog about memory operation for each allocation, the allocation, couple of logs there, and each action is probably doing a lot of operation with memory. So that can fill your log very fast. Memory join and memory safety. So joining was a bit of a problem in the past because or actually fragmentation was a bit of a problem in the past. We added memjoin that will join fragments that are next to each other when they become free available. Now we try to do it in like a dynamic way. When we discover we don't have any large enough chunk, we'll try to do join. But you can still enable if you want to be on the safety side. Mem safety is more about crashing or not when we discover problems with memory chunks, like maybe you allocated the memory chunk and you try to like free it a couple of times without resetting the pointer to 0. By default was like crashing in the past because the idea was to discover the problem. But I agree that in production, you would prefer rather having like a log message, well, guys, you are freeing or trying to access the memory when it's not allocated. So it might be good to enable that. Going to the next level of optimization. So now it's about modules. A lot of modules create their own hash table by themselves, not the module itself, but like TA module keeps the active transaction in a hash table, created only for that purpose by the TA module. User log does the same. So if you have 1 million users, they will be in a hash table inside Kamailio memory, optimized for the location services. Same with dialog and a couple of other modules. I'm not focusing on all of them to list them. But what's important, look at these modules you are using in the README. It's important to look at the README. And if you see a hash size parameter, that's practically something that you can tune. So especially for user log, if you have a lot of users, so I don't know, large deployment, probably you'll need to increase the number of slots. The balance, of course, is between allocated memory for the head of the slots, but if you have a lot of users, that is not. If you estimate to have, I don't know, 100 records, makes no sense to create a hash table with, I don't know, 16K slots. But if you have 1 million users in location table, then makes sense to have a large hash table. TM doesn't have, as far as I know, because it creates one with 64K. We said for transaction, we need to create enough for the users. Another thing that you can tune for performances will be the timers. Most of the modules that need a bit of timer operation, including user log, like scanning for expired location records, by default, they use the core timer. But you have a lot of records or a lot of modules using the core timer, then practically it's getting a bit overloaded. We added to most of the modules an option that they create their own timer processes, and it's good to do that for like user log or even hash table, because we have this auto expire, so we need to scan for expired records. If you expect to keep a lot of records inside these modules in the memory, create or configure the modules to create their own timers, including this not helper to send keep alive for keeping the pinhole open. So again, hash table sizes and timers. Look at your modules that you are using. If they have, think if needs to be tuned a bit. On the routing logic, this is more like some hints that you need to do. Of course, detecting attacks as early as possible. Otherwise, you're going to use a lot of CPU cycles to detect. I have to reject this traffic. As well as what I call here garbage traffic. There are a lot of devices sending keep alive themselves, like notifies of options. You can simply just send them 200 OK, even without authentication. Makes no sense to do authentication if you detect it's just a keep alive. Detection of the retransmission, it's also very important. We've been working in the last years to have a new method. And if you are not using pre-check trans, then you are not using the new mechanism. Look at it. Also, this is the part from the config file. The devel at this moment, the stable is more or less the same. So it's using pre-check trans along with check trans, the old single line that we use for retransmission. This is not creating the transaction, because transaction, it's a large structure in memory. It can create, it's by default with 12 outgoing branches. So we have one incoming invite with all the attributes stored in shared memory, plus structure for 12 outgoing branches by default. You can now tune outgoing branches number. Is no longer hard-coded. It's a module parameter. But anyhow, a TM or transaction structure is quite big. By using t-pre-check trans, you avoid creating that, and you still detect retransmission. And typically, the transaction is created by t-relay, which is more or less the last action you execute in your config file. So by detecting at the beginning of the config, or as much as possible at the beginning, after the attacks and so on, then practically you avoid running the config file up to the end. T-relay will detect, oh, I already sent out this request. I'm just discarding them. So by that, you get also some performance enhancement. Then authentication and authorization, do it before any other expense operation. Typically, database and DNS operation are sort of blocking or could take time. OK, authentication authorization could involve database operation, but that should be the first one. It's not like I'm trying to see, is this user enabled? Yes, OK, go further and then authenticate it. Because maybe it's not a good user. You query the database, and then you discover the user doesn't have the right password. What you can do with the modules, so there are about the internals of the modules or the logic in the config file now, optimizing or re-architecting your configuration file for enhancing the performances. First would be delegation of execution of a task to another process. as I said, logging or maybe just inserting records into the database for, I don't know, statistics, analytic purposes, you can delegate it to another process. The first option we had was MQ, message queue, which together with rtimer, which can create timer processes to execute routing blocks on an interval recurrence. And I have some example. If you look on the web, I had this like sending Twitter notification from Kamailio configuration file when you have like a missed call. So sending you a direct message DM, a Twitter DM. This is delegated to another process because you don't want to really block the SIP worker process until Twitter is accepting your request or not. So we delegate this Twitter HTTP request to another Kamailio process, which is never in charge of routing SIP. Later, we added async, which can do more or less the same operation by executing a route block in another process. You'll have to set that async workers to the core, and this module will delegate it, the execution to that. Again, it's a lot of situation where you do this kind of recording of the events doesn't really, or they don't have any impact on the next hop selection. It's just for monitoring or statistics and so on. Or delegate the execution to another application. So you can use here AV API, event API, where you can connect to Kamailio and then get some JSON formatted events. And then you can reply back, and Kamailio will pick it up from another worker processes and will route it there. RT-JSON is typically good to use in this because this defines a JSON format where you can say next hop attributes like request URI, destination URI, from header to header, additional headers. So you can push back to Kamailio in the format expected by this module. And this module then offers you the function to push it as next hop address or push it as parallel forking branches. So you can do serial parallel forking by returning to Kamailio a specific JSON format. How you interact with your application, again, AV API, HTTP async client. Federico is here, so he can do, if you need more explanation about it. It's asynchronous HTTP query. JSON RPC C, so JSON RPC client. The guys at FlowRoute developed it in the past, so they are also around here. Maybe not the initial developer, but they can eventually help. They use net string format, but also in asynchronous. That means just push it to an additional process, and the SIP worker is continuing the routing. Then the typical buses, message queues like RabbitMQ, quite popular, and recent NSQ could be used to send the traffic to another application and then get some feedback. So actually the example here is delegation of insert to custom database table called activity. So we use MQ and rtimer, the first solution I proposed. It's loading the modules. We define message queue. We choose our name. I put SQL, but it's up to you. You can define also many message queues to communicate between Kamailio processes. And then the rtimer. So the timer has two parameters here, the interval and the name of the timer. And the second one will be the exec. We say which timer to be used, TSQL, and what to execute, route from queue. In your, and SQL ops, of course, to connect to the database and do the query. This is to be executed typically from the request route. So when you have some SIP traffic that you want to keep a log of that activity, but instead of doing the query to the database, we push it to the message queue SQL. The key is not relevant here, but I'm using the from username. So the message queue works with items key value. And the value is the second parameter, which is actually on 2 lines. The variables will be evaluated, so will be for the current SIP message process. And the timer will pick it up from the queue in this route block. So we'll fetch it from the queue name, and then we just execute it, the connection ID from SQL Ops. And now we take only the value. So practically will be this from the insert to the end with the variables already expanded by the other process, because this timer process doesn't see that invite. And it's just executing the query. Of course, you can create many timer processes to fetch from the queue. This is like safe to fetch from many. We use synchronization there, so you can have as many timer fetching from the same queue as you need, depending on the traffic. So these are actually the tips and tricks I wanted to share with you these days. Probably there are a couple of more that you can look at, but they are more specific for different situations. I wanted to provide the generic ones that are kind of common to every configuration out there. Yeah, thank you for listening. I hope to have some useful information provided today. And now, questions if you have. Okay, questions. I have one here. I'll give it the monitor there.
Thank you. What is average amount of shared memory per one TLS process? Because some time ago this question was asked, but I searched for it and have not found it.
Yeah, I don't have an exact figure now to tell you, because most of the people are using now the latest algorithms, this forward privacy algorithm, which require a lot more. Actually, I can look here. For the past, it was Jan Janak, one of the initial developers of Kamailio. Okay. So if you look at Kamailio, I think it was green VoIP. Next, I haven't agreed. I don't use this. Typically, I have. I agree. Okay, let's agree on evil Google.
Just agreed to pay 10,000.
That was. I don't have change, but tomorrow. So here is the article on Kamailio website, so you can actually search on it, but lazy guys just use Google. And then I think we cache it somewhere. So this was done by the Columbia University, which is in New York, USA, and they try to measure how much energy is consumed by a signaling server. And the guys are using TCP and at some point TLS. And if you look inside the green VoIP article, hopefully it's still cached on Jan Janak's article. It's going here. How green is this one? Anyhow, at some point, here's some numbers here. You'll just have to look at it. If I remember, at that time was around starting with 64K, depending again, algorithm, key size, and so on. Again, just go and search for green VoIP, Kamailio, and you will see that. Maybe, I don't know, Federico might have a bit more figures as they tested, but approach him during breaks when they tested with, or ask on Kamailio mailing list, because these guys are there every night. I thought I'm from Transylvania and don't speak, but some of the guys on mailing list are answering now faster than me. Okay, so hopefully I was like giving you the right. If you really want to measure that, the way to measure, because there is a bit of overhead at the beginning with the initial structure, the typical way I do it for anything is like, let's say take it with the user location records. I load 100 registration, I take the snapshot of how much shared memory it's used, and then I put another 100, and I just measured the difference. So you can do the same, open either 100 connection, another 100, and see the difference of statistics. Other questions? I have Miko there. You should answer question, not ask question.
So if I use that password caching you
Yeah.
showed earlier, are there any safety requirements if something like a heartbleed happens? Is it different than with the normal authentication check, or if I load the password into the AVP variable?
Yeah, so that was with plain text password, but you can keep it in the hash mode first. So that's recommended. HA1 form, if you know the configuration file, is the same. You just have to provide another flag to the PV auth check saying now it's a HA1 form. And more than that, it's, if it gets access to the database that's locally, then it's like also getting access to memory more or less. So there is no extra protection than hashing the password, and that's recommended way. You can also remove as you want from the hash table, so from like command line if you want. So like when you change the password, you can correlate it with an RPC command. So you don't need to really wait always for auto expire to happen. Yufei?
I'm using this Redis, NDB Redis module,
Yeah.
and I find it creates quite a lot of TCP connections to the Redis database. Is it hard-coded, or can I control the number of the connections?
Well, normally it should be one connection per Kamailio worker. So if you start many workers, that's the same also with the database. And so like going to Postgres or MySQL would be a connection from each Kamailio worker. And that should be for the Redis as well, a single connection. I saw that Karsten added some Redis cluster support with multi-node addresses and so on. That might be more than one because it needs to go to more nodes. But probably you can ask him. I was using it only with a single Redis server, not providing a range of addresses. But again, the default one should be one Redis connection to the server per worker. If you define many server addresses, even if it's going to the same server but a different database, then could be a second connection. So again, to be more accurate, it's a single connection per worker to the database. So even to MySQL, if you connect to Kamailio database and to Asterix database, even they are hosted on the same server, will be a different connection ID.
I thought it was just a single IP, but I saw quite a lot of connections.
Yeah, because we create many worker processes.
Okay, yes.
So each worker has a connection to MySQL, to Redis, to whatever they need. But if you have many modules needing that connection, it's not like each module will open a new connection. We'll reuse the one from the worker, from the process.
Okay, I see.
But again, Kamailio, it's one application creating many processes. If you do a PS, grep Kamailio, you will see a lot of them. If you do chemctl PS, you'll get the list and the description, the role of each process of that instance.
Thank you.
Okay. Other questions? If not, I think for today we are ready to finish. Once again, big thanks to our sponsors making the event happening again. Flowroute, Telnix, SIPY, SIPGate, OBHI. I have all the names here. We appreciate the help. Tomorrow, don't party that much. This evening, gonna start early. Everyone is pretty much registered, only 40 or 30, 40 still registering, so it's not much time to lose at the registration, and we'll start sharp 9 with a bit of introduction, a bit of history, and looking at what we are doing now and in the near future. And then we go into different use cases by Kamailio, Asterix, and many other projects or technologies. And again, tomorrow evening, a bit of beer, finger food, and wine around here, so we can socialize a bit more than the usual. Lunch provided here, buffet, so you don't really need to plan anything. Will be proper food provided tomorrow, so you can also interact. Don't forget about those people out there to look at what they have to demo to you. OBHI, Telnix, the guys from Digium will bring their shiny new phones. Carsten Beck is willing to show their IMS platform, and we'll have the Focus core network dynamics showing you access to 4G, 5G networks. So they will be there tomorrow. And besides this, prepare your dangerous demos, I guess. James will hunt you tomorrow. If you don't register, they'll will hunt you for dangerous demos. If you have questions, we'll be around for a couple of more moments. Be sure you don't forget your belongings here. This is going to be locked, but we'll be cleaning stuff coming and so on. Please take care of your belongings. Thank you again. See you in the morning.